The High Altitude Observatory has been studying the greatest show on Earth for over 3/4 of a century. Not that kind. This show happens on an astronomical scale. Yes, we're talking about solar eclipses. You can predict when a solar eclipse will happen by knowing where the sun is relative to the Earth, where the moon is relative to the Earth, and where the moon is relative between the two. A solar eclipse happens when the moon is directly in between the Earth and the sun. This causes the moon to cast a shadow onto the Earth, creating a spectacle like no other. You might ask, if it's that simple, why has HAO been studying solar eclipses for so long? Well, it's a lot more than just celestial shadow puppet shows. Actually, humans have been curious about solar eclipses since before written history. While a lot of ancients may have freaked out seeing a solar eclipse, some of them started observing just what was going on. They were able to deduce what was happening, see a pattern, and in turn be able to predict when and where a solar eclipse would occur. Armed with that knowledge, they could claim power over others by suggesting that they had power over the sun. The Babylonians came up with the Saros cycle, a map that shows where and when a solar eclipse would happen. In fact, in 1901, off the coast of Greece, explorers found a strange device in a shipwreck. It's known as the Antikythera mechanism, an ancient computer from around 200 BCE that can predict celestial bodies, phases of the moon, and, you guessed it, solar eclipses. But knowing when and where is just the start of the knowledge we've gained. You see, we are particularly lucky here on Earth because the moon's diameter is 400 times smaller than the sun's. But it's also 400 times closer to the Earth, making them appear almost the same size in the sky. That allows us to get a look at the sun's corona, a Latin word in origin, today in Spanish means crown. The corona is an area of superheated plasma that surrounds the sun. We couldn't see it if the moon didn't block out the rest of the light coming from the sun. And what did telescopes find when looking at an eclipse? Huge solar storms, many times the size of Earth, that burst forth from the sun. As technology has improved, we've learned more and more from solar eclipses. By pointing a spectrometer at the corona during an eclipse, we accidentally discovered helium. Yep, before balloons, the only helium we knew was on the sun. We've been able to lend evidence to Einstein's theory that gravity bends light by comparing light from stars that appear close to the edge of the sun. And now we've built and improved on the coronagraph, a device that blocks out the sun and redirects the excess light so that scientists can study the solar corona whenever they want. And what have they discovered? Amazing things! For instance, sometimes we think of astronauts jetting up into cold, dark space, leaving our atmosphere behind. But the Earth actually lives in the sun's atmosphere. Energetic particles shoot out from the sun and get deflected by the Earth's magnetic field. That's what keeps us safe and makes those beautiful auroras at the Earth's poles. But the sun also produces coronal mass ejections, or CMEs. A big one can disrupt our magnetic field, interfere with satellites, communications, and in rare cases, even shut down power grids. We've even discovered solar cycles, patterns in the occurrence of solar storms that rise and fall every 11 years. Being able to predict these events is one of the many reasons HAO continues to study the sun, solar eclipses, and their impacts on Earth. And they are using every tool at their disposal: telescopes, models, supercomputers, coronagraphs, satellites, observations, and good old brain power. Yes, there is still much to discover and more to learn about that great big life-sustaining ball in the sky. And HAO is on the case.